Hello and welcome to our review of inequalities. We're going to focus on systems of inequalities, but what works for a system has to work for one or both inequalities. So you'll see the review of how to work with individual inequalities as part of a system. And we're going to identify solutions either by plugging in the values if they're given, as well as by checking our answer, and then to graph inequalities, which is the typical way we solve a system of inequalities or an inequality. Then finally, we're going to solve word problems. And let's talk about some of the main ideas from the unit. Vocabulary-wise, we have the symbols greater than or equal, which includes values, less than or equal. The rules for graphing these inequalities, if we have two variables, we have a dashed line, and we shade above if it's greater than, strictly greater than. We have a solid line shaded above if it's greater than or equal. We would include the values on the solid line. Less than is a dashed line shaded below, and then less than or equal, solid line shaded below. And this is a quick kind of a way to identify how the graph should look. We look at the green here, it's dashed because they're not or equals, and then if it's less than or equal shaded below, likewise greater than or equal is above. And then finally, whenever you multiply or divide an inequality by a negative number, you must flip the direction of the inequality. So if you did have a greater than and multiplied or divided by a negative, it would turn to less than, and vice versa. And now we'll try to determine if we have a solution to a system of inequalities by substituting in values and seeing if it makes the inequality true. In this case, basically if we check both of them and the solution, the point works for both of them, it's a solution to the system. We'll plug in a 0 for y, -3 for x. Negative times a negative is positive. That becomes a positive. 6 minus 1 is a 5. That is true, so it is a solution to the first inequality. Plug in 0 for x, -3 for y. We get 0 is greater than or equal to 0. Barely true, but still true. So -3, 0 is a solution to the system of inequalities. Same thing over here. We'll plug in -1 for x, 5 for y. We get 5 is less than or equal to 0. That is not true. We can stop right there. Even if it's true for the other inequality, it would not be true for the system. So this is not a solution. In order to graph inequalities, we're going to use this kind of a cheat sheet here to graph the boundary, and then we shade. And by graphing the boundary, we basically graph the line, wait until we determine if it should be dashed or solid, and then shade above or below. So for instance, looking at this system of inequalities, we would have the equation going through the y axis as a y-intercept of 1. It is less than or equal, so it's a solid line. Less than or equal would be shaded below. And we'll show that this way. Then greater than 2 is going to be a horizontal line, and it's dashed. And we can shade that with green. And that gives us this region right in here. So all of these values, all these coordinates would work. And I'll go ahead and erase the blue. Okay, if we wanted to, we could check those answers just to see, and I encourage you to do that, especially on the test. And now we look at this second system of inequalities, and we'll look at the first one here. This has the y-intercept already solved for. It's a +3. We know that the slope is +4 up 4 over 1, and then it's less than, meaning it's dashed line shaded below, so we'll take and shade this guy below. Using your pencil on its side probably makes a little better graph. Okay, so all this region, and then the second inequality has a problem here. We need to solve it for y just in case it causes us to multiply or divide by a negative. So we'll add 3x to both sides and divide by 2, giving us y greater than or equal to 1. 2 over 2 is 1 plus 3 over 2x. We didn't need to flip the direction, but it's a good idea to make sure that that's the case. Y-intercept is 1, up 3 over 1, and we're going to be a solid line because it's or equals, shaded above in this case. So since I know this is the region, I'm going to go ahead and just shade in here with the blue, and I know that any point in this region works. Obviously, this is also part of the solution of the single inequality here, but we're looking for solutions to the entire system. So I'll go ahead and erase the green, and that gives us a nice view of what we have for our solution. And let's go ahead and test this out. We'll pick a point in here and check it. 2,5 looks like it should work, the 0.25. If I were to plug in a 2 up here, a 5 for y, I get 8 plus 3, that's 11. So 5 is less than 11, it works there. Plug in a 2, I get negative 6 plus 5 times 2 is 10. That's a total of 4. 4 is greater than or equal to 2. So the 0.25 is a solution. I feel pretty confident about my answer there. We're about to talk about some word problems, and what we want to talk about here is how to identify the symbol that would go with the words. And just under, or the typical ones are less than, greater than, less than or equal, greater than or equal to. But you might read somewhere in a word problem that a value is just under, or more than, or at most, or at least, up to, down to. These are all the amounts being either less than or greater than or equal, less than or greater than. So you want to look for those words and identify them. And I would encourage you to think of others and add to your list and make that part of your study information. All right, so if we set up a word problem here, we first read through it. We see that Ed can mow at most 9 times. At most, that's an important phrase we want to look at. 9 times, and rake at most 7 times. He charges $20 for mowing, $10 for raking. He needs to make more than $140 in 1 week. Show and describe all the possible combinations of mowing and raking that Ed can do to meet his goal. List 2 possible combinations. Well, first let's identify the variables. X I'm going to have equal the number of mowing jobs, and Y is the number of raking jobs. If we look throughout the words there, we see that he can do at most 9 mowing jobs. We write that as X is less than or equal. At most is less than or equal. Likewise, if you look right after that, it says rake at most 7. And finally, we see that he makes his money by making $20 off the mowing, $10 off raking, and he wants to make at least $140. Or more than. I shouldn't say at least, because 140 isn't enough. He wants more than 140. So if we were to look at the inequalities here, we have x is less than or equal to 9. So we go to the vertical line of x equals 9. We draw that shaded to the left in this case. So it would be all this space over here, all the way over. And likewise for the y less than or equal to 7, we find y equals 7, and we would shade below that. So that's down here, all of it. And then our last one, greater than 14 minus 2x. Starting at 14, we'll go down 2, right 1, down 2, right 1. And that would be greater than is shaded above. And so this looks like the region that we would have. Now I don't go any lower here, even though my arrows don't intersect. And the reason is there's some common sense constraints here. He can't mow negative yards, and he can't mow or rake negative yards either. So common sense wise, x has to be greater than 0 and y has to be greater than 0. I guess it could equal 0. And the reason I haven't shaded below the x-axis in this case is because there are some what I call common sense constraints that he can't mow a negative amount of yards, and he can't rake a negative amount of yards. So I would shade this all in the first quadrant, have it all shaded just to show that I can't have any of the information that's unreasonable. So I don't make a big deal about that because it's obvious to an extent, but I do want to make sure you understand that. And let's follow up just a little bit further. It's not asked, but let's find out how we can make his most profitable scenario. And what we find is out on the corners where you find your best options. That's what we learned from linear programming. So let's choose 9, 7 as one of the points. And and I'll use green, 9.7, and also because he can't really rake half a yard and try to get paid for it, or in this case mow half of a yard, we're going to go ahead and go whole numbers. So let's plug in 9 for x. That's going to be 20 times 9. I'm going to do the math in my head. 180 plus 70. That's $250. That's clearly going to satisfy the constraint of 140 as well. And then 9 times 20, that's still 180 plus 40. That's 220. So his optimum situation to make $250 is going to be at the 0.97 out here. And that makes some sense. The most lawns that he takes care of by mowing and raking. All right, well, you might have more questions. We have time to review, but make sure that you document the things that make sense, the things you think are on the test that you need help with, and good luck on the test.